Welcome back, Senior Devs. Sean Cannon here. In this lesson, we're going to talk about security. I want to start off by listing 3 laws that I live by when it comes to securing my projects. Live by these 3 laws and you will give security the attention it deserves. Law number 1, always assume your users are smarter than you. I see this time and time again on projects where the application will have a security exploit and the dev team will brush it off as a low risk because the only way to exploit can be achieved is if a user knows how to do something clever. Some of the best hackers in the world are among the smartest people in the world. The moment you think the site is secure enough is the moment when you should obtain a security consulting firm to run penetration tests on your system. We'll come back to this in a little bit. Law number 2, if your project is a backdoor, assume everybody knows about it. Obfuscation is not security. Just because your application has a big sign that reads enter here doesn't mean that everybody will do that. If your website has a query string parameter that allows admins to bypass the login, then you need to act as if that is in the public issued docs and everybody knows about it. People leave companies, people talk, people get hacked. One example might be, imagine some contractor working on your project upgraded their hardware and the company reissued their laptop to another contractor not on your project. There's a risk now that the new contractor will have access to the browser history on that laptop and see the backdoor. You can't assume this new contractor won't snoop or won't care. You can't assume the contracting firm will wipe their laptop disks on reissuance. You need to assume the worst. Law number 3, always assume if your application is breached that you will lose everything. Seemingly innocent oversights have brought down entire companies before. Even if there was a breach and no data was actually leaked, that has to be disclosed to customers and it could result in millions of dollars lost simply because customers lose trust and they decide to put their money elsewhere. So I want to reassure you of something now. Not only do you not need to be a security expert to secure your project, I recommend you stay somewhat ignorant or at least remain humble as you learn and improve. There are entire companies who specialize in security and it's their job to keep up with all the latest exploits out there. It's almost impossible to keep up with every security precaution and best practice if you're a full-time developer. So, while you don't have to personally know about all the exploits, you do have to do everything in your power to ensure your system is able to be audited over and over for security leaks, and you do need to have security on your mind front and center throughout the entirety of building and running your project. If a breach does ever happen, you want to make sure you can show that you covered all your bases and followed all the recommendation guidelines and best practices as directed by SecOps and any external security forums doing the audits. You do not want to reassure the executives that all your security precautions were enough and that their system is secure. Completely contrasted, we as software professionals should be humble and untrusting of any security precautions in our system. We want that executive all clear to come from a multi-million-dollar security firm, so if the project does happen to get breached, the blame stays up high at the executive level. Ironically, having said that, I've been on several projects where the SecOps team really didn't know what they were doing, and the pen testers weren't really penetrating anything exposed to the public. For example, one of the tests complained about plain text passwords in my spec files, which of course was just a literal string to create a temporary test user that was immediately deleted when the next unit test ran. Not all security analysis software is intelligent, and often you'll feel smarter than the security auditor, but at the end of the day, it's not the ones and zeros that matter here. It's corporate and customer data, intellectual property, and system credentials. Losing control of any of it simply cannot happen. So, while I recommend avoiding confidence in the security space, I do want you to have competence. So, what are some security precautions we know we need to do always? Short-lived tokens. Tokens get passed around, and the longer they remain valid, the more they are at risk of being intercepted and used by someone posing as you. One-way hashes. I highly recommend using one-way hashes that need to be recreated for validity confirmation instead of using encrypted tokens that can be decrypted with a key. If anybody gets the key, your whole system is at risk. One common example for this is user passwords. You should create and store one-way hash for the password. The user will then provide a plain text to log in, which is then hashed, and you simply compare the hashes. If they match, the user is legit. You should also salt your hashes with a relatively high exponent factor to slow this process down. You want this step to be noticeably slow to help mitigate brute force attack risk. Stored one-way hash passwords are great, but brute force attacks previously mentioned are extremely common. If the hacker is able to guess a password simply by trying hundreds of millions of passwords, then how secure is your system really? Even if the speed of your hash is curbed by salting, we can take additional steps to enhance security even further. Multi-factor authentication means that even if a hacker guesses a password, the owner of the password still needs to confirm both the login intent as well as a one-time short-lived token from a separate physical device. Make sure your app demands long, complicated passwords from your users. An 8-character password can be easily cracked no matter if it contains special characters and uppercase letters. A 60-character password risks there not being enough time in the universe to crack it. When I first wrote this module, the Wells Fargo login lowercased all password and restricted the password length, so my login was both case insensitive and easy for a hacker to eventually guess. Even the biggest companies who you would think would be ultra secure are just terrible with security. Be better. In your system and in your company, you want the entities to only hold keys for locks that apply to them. For example, if you have 20 microservices but only one of them connects to Amazon S3, then that's the only one that should have access to Amazon S3. For engineering, the UI team does not need the production database password. Every entity that holds a key risks losing the key, abusing the key, or having it taken away from them by an attacker. When you're dealing with other people's information, you need to assume the worst case scenario. Only give people access to what they need to do their jobs. Keep track of and reassess that access regularly, and only expose credentials and keys in environment variables to systems that need the keys to function properly. I want to talk a bit now about authentication versus authorization. Authentication is essentially identity, and authorization is essentially permission. While they both live under the same security umbrella, I often hear developers conflating the two, even though they are very different. Setting your project up for authentication is essentially putting a login gate between the user and the application. The user provides some form of identifier and credentials for proof, and our system either looks up the user based on the identifier and validates the proof, or delegates that step to another identity provider using OAuth or a similar approach. Authentication is essentially going to a concert, showing your ticket to the bouncer, and in turn, they put a green wristband on you and let you in the door. Authorization is essentially whether or not your wristband lets you go anywhere in the venue or only some places. Maybe you try to get backstage with your green wristband, but a separate bouncer says, sorry, you need a VIP badge, for example. So if a login gate covers the basics of authentication, how do we handle authorization? Can't the login gate handle both? Yes, it can, but only if everybody using the application has the same permissions. This is a common pattern when you compartmentalize apps through subdomains or routes where each app has its own login. Maybe your website presents www.myapp.com to customers and admin.myapp.com to employees. If you're developing a mobile app, you might have an app dedicated to customers and another app entirely dedicated to internal staff. Each of those apps can then only know about the APIs that apply to their respective users. This follows the separation of concerns principle and makes authorization handling quite simple because you essentially only have to do that one security check at the front gate. If, on the other hand, you have an application which presents a common UI to users with varying permissions, then you need to adopt roles and permissions into your identity layer so you can check them at the permission layer. In our concert analogy, maybe some folks have a green wristband, some have a media pass so they can take photos on the main floor, some have a VIP badge to go backstage, and so on. That venue can't just have one bouncer at the front door, it needs to have one at each designated area. These bouncers on the inside only care about your badge, not your ticket. Only the front door bouncer cares about your ticket. If you had to carry your ticket around the venue and prove its validity to each bouncer, it would not only make security extremely slow, but it also increases the likelihood that you drop or lose your ticket or that someone else steals it from you. The principle of least privilege tells us that only the authentication gate knows about the password, not the authorization gates. In my projects, I typically use RBAC, which stands for Role-Based Access Control. It's broken up into 4 main data points: roles, resources, role assignments, and permissions. Roles are essentially just a name for a typical position. I recommend avoiding using simply admin because in RBAC, different roles can get permissions to different resources and permissions can cross over each other. So admin becomes a very fluid term, like you're an admin of what? I prefer using real positions or a shared department role, like tech lead or customer support manager, SecOps, something like that. It makes it so much easier to correlate who is most likely to need access to what based on their daily responsibilities. Resources are entities in your application which need to be gated. Most of my project work is web development, and so I consider a resource to be a combination of an HTTP request type and action. For example, if we have an API endpoint for /user, I typically define 4 resources, one for each post, put, get, and delete. Identity and ownership create a bit of a challenge in RBAC when used at the route level for APIs because they require additional middleware lookups, but in my opinion, it beats the alternative of adding overhead by including database records as resources. In other words, we may want to give a user permission to update their own profile, but not everybody else's profile. Or maybe we want to give a user permission to update anybody's profile. Defining the resource at the API route becomes slightly ambiguous unless we split the routes into well-defined administrative routes where it's clear that the intention of the route is for token holder to act on behalf of other users. Role assignments are essentially just mappings of roles to users. This is a many-to-many. Many users can be assigned a role, and a user can be assigned many roles. For example, maybe a user works in multiple departments, or maybe multiple departments use the same endpoint in their workflow. Permissions are essentially a mapping of roles to resources. This is also many-to-many. Many resources can be assigned a role, and a resource can be assigned many roles. I mentioned briefly the need for middleware on some of the routes. This is just a platform preference, and it's ultimately up to you. For the concert venue analogy, this is just a matter of deciding whether or not the backstage bouncer is outside at the back door checking a ticket, or inside the venue near the side of the stage checking wristbands. Most of my examples come from a bias towards web development, but behind the scenes is really the same when we consider desktop applications, game dev, mobile dev, and so on. Define and expose the entry point for users, validate the users, assign the users a badge with some roles attached to it. Then, various actions in your application which should only be exposed to those roles should do those role checks there. Try not to reference specific roles throughout your application logic, or you will clutter up your code with security checks. This is why I use middleware. If you are using object-oriented programming, you can use a superclass which does some security checks behind the scenes, for example. Ultimately, security starts with you. Lead by example. Most of the time, computers are hacked not by some elaborate spyware, but because people write their password on a post-it and stick it on their computer. I personally use an app called 1Password to store all my online credentials. Most of my passwords are 50 to 60 characters of random gibberish. It's actually pretty funny watching my kids spend 15 minutes entering the PSN password with a PlayStation controller when they're trying to buy a game. I also use multi-factor auth for everything. MFA is a no-brainer, folks. It's literally the difference between a hacker stealing your identity from a website and a hacker telling the website to send you a notification telling you to change your password because it's been compromised. Junior devs on your team will notice when you put security first in your life and in your projects, and it's very common that your good habits will rub off on them. Leading by example is a much better approach to most things than simply lecturing and nagging. To summarize this module, always be thinking 20 steps ahead when you code. Pretend every user is trying to break your application and steal what's behind the curtain, and if that happens, pretend your entire career is done and you have to personally apologize to everybody whose identity was stolen. With that paranoia in the back of your head, you'll be smart to defer responsibility and sign off to big security firms and the SecOps team whose literal job it is to sign off on security. Let them handle it and do everything in your power to support them and go above and beyond their bare minimum requirements. Remember, you still have to do the work, but they need to grade it before it goes live. That wraps up this module. Keep growing, and I'll see you in the next one.